In 1967, a graduate student found a radio source ticking every 1.3373 seconds, so precise it looked manufactured. Her lab labeled it LGM1, Little Green Men. They were wrong, and nearly 60 years later, we are finding objects that break the rule which proved them wrong. I'm Rook. This is Odd Signal, Cambridge, 1966. Jocelyn Bell Burnell is a PhD student, and she has just spent 2 years helping build a telescope by hand. 2,048 dipole antennas strung across 4 acres of English field, tuned to 81.5 MHz. It was designed to study quasars by watching them twinkle through the solar wind. There were no screens. The output came out on paper, in ink, roughly 100 feet of chart recording every single day. And Bell Burnell read all of it herself, which is why the paper kept coming, and why she noticed something half a centimeter long. She called it scruff, a small, ragged smudge in the trace, not a quasar, not interference from a passing car or a badly shielded motor. And it came back, not just once, but again and again, always from the same patch of sky. So they ran the recorder faster to stretch the signal out, and the scruff resolved into pulses. Each pulse lasted about 0.04 of a second. The gap between them was 1.3373 seconds, holding steady, more regular than anything natural anyone knew of. Nothing in the sky did that. Clocks did that. Machines did that. So they considered the obvious, uncomfortable possibility and wrote LGM1 on the source. What killed the alien idea was not an argument. It was a second source. Bell Burnell went back through the charts and found another pulsing object in a completely different part of the sky at a different period. Then a third. Then a fourth. 2 civilizations on opposite sides of the sky, broadcasting identical meaningless ticks at us, was not credible. Whatever this was, nature was making it, and making it often. The answer turned out to be a neutron star. Take the collapsed core of a dead massive star, squeeze roughly the mass of the sun into a ball about the width of a city, and it spins fast. It carries a magnetic field, trillions of times stronger than Earth's, and it fires beams of radio waves out of its magnetic poles. If a beam sweeps across Earth, we see a tick, a lighthouse, seen from far out at sea. They were named Pulsars. The Crab Nebula holds one that flashes about 30 times a second, sitting inside the wreckage of a star that exploded in 1054, an explosion recorded at the time by Chinese astronomers. And so the label came off. LGM1 became PSR B191921, one of thousands of pulsars we now use as instruments. We timed them to weigh distant stars, to test Einstein's gravity, and to hunt for gravitational waves rolling through the galaxy. Then the prize went elsewhere. The 1974 Nobel Prize in Physics went to her supervisor, Anthony Hewish, and to Martin Ryle. Bell Burnell, who spotted the scruff and insisted it was real, was not included. She has consistently refused to be bitter about it in public. In 2018, she was awarded a special breakthrough prize in fundamental physics, worth $3 million. And she gave every penny of it away to the Institute of Physics to fund PhD scholarships for students from groups underrepresented in physics. That is where the story sat for decades. A mystery solved, and honestly one of the cleanest solutions in modern astronomy. Except for one detail buried in the theory. There is a line where it should stop. A pulsar runs on rotation. As it spins down over millions of years, the voltage it can build across its magnetic poles falls, and below a certain spin rate, the radio emission should switch off completely. Astronomers call it the death line. Cross it, and you go dark. Most known pulsars turn once a second or faster. Some turn hundreds of times a second. In July 2023, a team led by Natasha Hurley-Walker reported an object that pulses once every 22 minutes. It is catalogued as GPM J183T9-10, about 15,000 light-years away in the constellation Scutum. Every 22 minutes it releases a burst of radio waves lasting up to 5 minutes, then falls silent. By the deathline, it should not be able to do that at all. It is not sitting near the line. It is far past it. And then they checked the archives. The archives already had it. Old observations from the Very Large Array and the Giant Metrowave Radio Telescope, going back to around 1988, contain the same pulses. The object had been transmitting for at least 33 years into datasets nobody thought to search, because nobody expected anything to be there. 33 years of a signal, sitting in storage, waiting for someone to look. It is not alone. There is now a whole class of these things, called long-period radio transients, and the discovery rate is climbing. One of them, ASCAP J1935-2148, has a 54-minute period and switches between 3 completely different emission states, including one where it goes quiet altogether. Another, ILT J101.5521, pulses every 125.5 minutes, and turned out to be something nobody had predicted. A white dwarf and a red dwarf orbiting each other, where the rhythm is the orbit itself, not the spin of a single star. By 2026, around 15 of these objects had been confirmed. So where does that leave us? Here is the honest scoreboard. LGM1 is solved. Pulsars are understood well enough that we no longer study them as puzzles. We use them as tools. That is a finished piece of science, and I am not going to dress it up as anything else. The slow ones are not one answer. Some are binaries, where the clock is an orbit between 2 stars. Some may be neutron stars still emitting long after they should have gone quiet, which would mean the deathline is less aligned than a strong suggestion. No single model covers the whole class, and the population is still growing faster than the explanations. In 1967, a signal that repeated too perfectly made serious scientists write little green men on a folder, and they were wrong. In 2023, a signal that repeats too slowly is doing something we still cannot account for, and this time nobody is reaching for aliens. They are reaching for new physics, which is the stranger result to you, that the first one turned out to be a dead star, or that the new ones are still open. Tell me in the comments. Subscribe if you want to be here when somebody finally explains what pulses every 22 minutes. This is Odd Signal. Keep listening for the strange ones.